All right, guys, so here is a brief explanation of the last couple things that we need to know for the organic molecules test, which is coming up at the earliest Friday, but probably Tuesday, Wednesday of next week. Okay, so the last things we need to know are cyclo compounds, ethers, and esters, which are named similarly, and substituted benzenes, which we'll get to in a second. So, cyclo compounds. Sometimes the backbone of the molecule is not all in a line as we are used to. Sometimes it is actually in a circle, as this one is right here. So we have a six-membered carbon ring, 1, 2, 3, 4, 5, 6, and we have some things on the outside, some chloro groups, a ketone, and so there's a few differences in the way that you need to name this. There's a thing you need to add and a thing that's different in the numbering. So, one thing is, you don't have to start on one of the ends like we did with a linear compound anymore. You can start at any carbon that you want for the numbering. And so you must strategically do this to keep your numbers as low as possible. For example, in this compound, I would probably start with this carbon as number 1, and then I would say this carbon is number 2, and I'd continue numbering around in that way. These other carbons don't really matter because there's nothing on them, but that's how I would number the carbons. 1, 2, 3, 4, 5, 6. In this way, there's 2 things on carbon 1 and 1 thing on carbon 2. So all my numbers are going to be 1s or 2s, which is the lowest possible numbers. The other thing you need to add to the name is you need to add something right before the name of the backbone. So how this thing would be named, we have 2 chlorines and we have a ketone. So the chlorines are prefixes and they turn into chloro groups, and this is a suffix, and that changes the N to -one. So this would be 1,1-dichloro. Then the thing you have to add is right in front of the backbone, which is what would come next. You just have to add the little tag cyclo right in front of it. So this is 1,1-dichloro-cyclohexa, and hexa, because we're going to put some suffixes on there, specifically the -one for the ketone, 1,1-dichloro-cyclohexa 2-one. So the only difference is, got to add that little tag cyclo. When you have a cyclo compound such as this, we still need the hydrogens, and we can add, or we can start numbering wherever we'd like, in this case on the chlorines, right there. So that's how you name that one. So for this one, a bunch of stuff on there, including some double bonds, and we can have double and triple bonds on our cyclo compounds as well, although triple bonds are much more rare. So I would probably start this one right here with this ketone, and I'd go that way. That way everything is as low a number as possible. So I'll probably start 1, 2, 3, 4, 5, because everything's then going to be on carbons 1, 2, 3, 4, or 5, because you name the double bond for the first carbon that it's on, the lower of the 2 numbers. So we have some groups on here, some of them prefixes, some of them suffixes, and we have 1, 2, 3, 4, 5, 6, 7, so that's going to be heptane in the backbone. So the prefixes, we go in alphabetical order as we know. So on carbon 4, we have 4 amino, so that's our amine group, so 4 amino, then 2 fluoro, then I think that's actually all for the prefixes, so we shouldn't actually have a dash there. So it's in a circle, so that's cyclo, hepta, there we go. Cyclohepta, hepta because there's 7 carbons in cyclo because it's in a circle. Cyclohepta, and then we have ones, and we have enes, and we have an ol. So we have, oops, that's not an one, that's an ol. This is an one. There we go. So we have enes, ols, and ons here, and so which one comes first alphabetically? Ene comes first alphabetically. So this is cyclohepta 3,5-diene, and I'm going to run out of space, so I'm going to continue down over here, which is perfectly fine. And then L comes before N alphabetically, so we'd say 2, 3, 2, 3, diol, then 1, one. So 3,5-diene, there should be a dash because there's between a letter and a number. 2, 3-diol, 1, one. So that'd be the name of that one. Did I get everything? I think I did. Okay, so that's how you do cyclo compounds. You just have to add the cyclo in there in the name, and you can start numbering wherever you'd like and strategically number it such that the numbers are as low as possible. You number starting wherever, and you can go in any direction. I could just have easily started here and then gone the other way, but then there would be something on carbon 7, so blah. Okay, for the next couple things, for the last 3 things that we have, the naming is actually fundamentally different than we've seen so far. For ethers, An ether is anything that has an oxygen that's in the middle of the carbon chain, like we see here. So here we have an oxygen in the middle of the carbon chain, and we have some carbons on either side. And that qualifies as an ether. If it was on the end, it would be an OH, like up here, and that would be an alcohol. That's not an ether. So we name these in a fundamentally different way because we don't really have a continuous carbon backbone anymore. So we name it for the side chains pretty much only. If this were a side chain on a larger molecule, this would be called methyl. And if this were a side chain on a larger molecule, that would be called ethyl. And so we put them in alphabetical order, and we say ethyl, methyl, ether. And so we don't name it for anything else. We name it ethyl, methyl, ether. And so that's the ether in the middle, and there's an ethyl group on one side, and there's a methyl group on the other. We don't name anything else. Now, obviously, there can possibly be other stuff. There could be like a ketone on here, or there could be like a fluorine or a hydroxide or whatever it happens to be, or a double bond, but we're not going to learn any of that. We're just doing the basics. So that's just ethyl, methyl, ether. And there's technically a space between methyl and ether, but it's okay. If you leave a space or you don't leave a space, I'm not going to count it off. The only other thing that we need to know, if it's the same group, like we have here, these are both ethyl groups, rather than saying ethyl, ethyl, ether, you just say di-ethyl ether. And this is the compound that actually was extremely important in surgery before we had nitrous oxide and lots of other crazy anesthetics. Excuse me. So, that stuff, but it was really nasty. You would usually vomit when you came out of the anesthetic for that, and it was all, It's good to have, though. They didn't want a person writhing around while you're performing surgery on them. Before this, they had to hold people down while they cut into them in person, shaking all over the place. And so a good surgeon was a fast surgeon back then, but anyway. Okay, the next one is called an ester group, and it's this group right here. And again, like an ether, it's in the middle of the carbon chain, so it kind of disrupts the carbon chain in the middle, like this one does. So, and just like an ether, we just name it for the sides. We name it for the things on the sides. So this 3-carbon chain, this is a propyl group, and this 4-carbon chain is a butyl group. And so we put them in alphabetical order, and we say butyl, propyl, ester. Butyl, propyl ester. Butyl, propyl ester is the name of that compound. So that is that one. Now, the next thing is there's a structure like this that is very, very common in organic molecules. All through nature, we see this structure in amino acids, in various neurotransmitters, in fats, and actually not in fats, but other structures and whatnot. This is a very, very common structure. And we commonly see it abbreviated like this. It is a cyclohexane that has double bonds on carbons 1, 3, and 5. So technically this would be called cyclohexa-1,3,5-triene. But because it's so incredibly common, it gets its own special name, and that special name is benzene. This is the structure of benzene, or this little abbreviated structure right here. So benzene is so incredibly important to organic molecules that it actually gets some of its own naming system. You can call it benzene, so if we just attached like a chlorine to this would just be chlorobenzene. Or even some benzene compounds that just have one thing attached get their own special names. Like, for example, if you have a benzene compound with just a CH3 up here, this is called toluene. But, you don't need to know these names, really. But what you do need to know is this. Very, very commonly, we have a benzene with 2 things attached to it, 2 and only 2 things attached to it. So the way we would name a compound like this is for the side chains, for the structures. So we have a CH3, which is a methyl group, and we have an NH2, which is an amine, so we call that amino as the prefix. And so we don't say 1, 2 anymore. We don't say like 1 methyl, 2 amino, or actually it would be 1 amino, 2 methyl benzene. Instead, we call this arrangement. So we say the names of the side chains, which is amino, methyl, benzene. But if you just say amino-methyl-benzene, as we have right here, we don't know where they are. We don't know the arrangement of these 2. But a benzene ring with 2 things attached to it is so incredibly common and important that it gets its own naming system. If the 2 things that are attached to it, and 2 and only 2, it doesn't work if there's 3 or 4 or 1, if the 2 things attached to it are right next to each other on 2 carbons that are adjacent, then that is called ortho aminomethylbenzene. The ortho arrangement means they're right next to each other. The ortho arrangement means they're right next to each other. If they are not right next to each other, if there's one carbon in between, so here we have a fluoro group, and here we have a chloro group. So, and both of those are prefixes. So in alphabetical order, this is chloro, fluoro, benzene, chlorofluorobenzene. If there's one carbon in between, this is called meta-chlorofluorobenzene. It's called meta-chlorofluorobenzene. So the meta configuration means there's one carbon in between, and it doesn't matter where they are as long as there's one carbon in between. It could be on these two carbons down here, right here and right here, fluorine and chlorine. It's the same compound because there's one carbon in between. So that is called the meta configuration, metachlorofluorobenzene. And finally, if there are two carbons in between, and we have some side chains going on right here, both of those are prefixes. So this is the ethyl group, and this is a butyl group. If we have two carbons in between, essentially they're on opposite sides of the benzene. Doesn't matter which two carbons they're on, as long as they're on opposite sides of the benzene. This is called the para configuration. So that's para, and again in alphabetical order, butyl, ethyl, benzene. Okay, and that is the last thing we need to know. So now you guys know everything you need to know to do the review and to be successful on the quiz/test, which is at the earliest it would be Friday, probably more like Tuesday, Wednesday, because we have Monday off. Probably more like Tuesday, Wednesday of next week. Okay.